Hey guys, I'm Nick, and in this tutorial we will take a look at the UV glowing effect, which was inspired by this effect from Gabriel Morella. Here you can see a really cool blending of colors and all of these little details and swirls. In our result, we are mostly focusing on creating these swirls, so we will be using some forces, some noises in combination with Vellum. Alright, and here we are in Houdini, so let's check this setup. First thing that I want to mention is in this project, and especially for this scene and setup, I'm using this camera, which actually has really unusual focal length. Which is in this case set to 20. Usually I'm using like 80 or 125, but for this one I really thought that I want to get that distorted look, so yeah, we're using 20. I tried with 16, but yeah, actually I think 20 works the best. And we have two cameras, camera 2 and camera 1, which is this close-up thingy, and we'll talk about the materials and just these two lights a bit later. Right now, let's go and check the setup, and yeah, here you can see that it consists from like three logical parts, which first being collider, second would be our Vellum constraints, our Vellum geometry, and then our simulation, meshing, and all of that stuff. So let's begin, and maybe let's pop out of this camera. Really, you can see that it looks a bit distorted here, and that's the thing with a 20mm focal length. And here basically we have just a setup of a collider, which is this one. It's basically a tube, and then we have two other tubes. We get these two, one is like a larger and one is smaller, and then we apply the boolean and we have this protrusion in our tube. I'm using transform just to kind of push it down a bit. And here I attach that into boolean, and then I had this or like collider shape. Basically here all the particles will swirl around. All right, so now we need two outputs. One is this just basic your geometry, your out shape collider, and what I'm doing here is I attach the transform node here, and this rotation here is actually, it's like rotating 0.1 each frame. So here you can see it's just really slow rotation, as we have a bit of friction in this collider to our, let's say, paint blobs. It actually helps to break the uniformity just a little bit, just like small little addition to the forces. And then we also need to connect our boolean to this VDB from polygons, and then we apply VDB reshape SDF. So the thing with VDB from polygons is that for this setup, voxel size should be set to 0.01, and then we add another null and call it out VDB collider, and this is for our collision geometry, or actual collision solver in our DOP network. So then for the actual paint blobs, we have these little spheres here, and then I attach the points from volume. Point separation is set to 0.007, and here you can see that if I click on it, it says channel controls psep, and what the hell is psep? Actually, we have my null here, which is called controls, and you can click the gear icon, edit parameter interface, and then you select whatever type of parameter you want. You can drag the float, for example, and here you can say, I don't know, p scale, and then call it scale or something. And then you can, let's just remove this p scale for now and leave our separation, which is called psep. Basically name is how it will be referenced in the code, and label is just like how it will be visually represented. Here you can see that I set my separation to 0.007, and then I can go and copy parameter, and here go back into my point from volume, and I can click here and select paste relative references. And now if I change it here to something like 0.009, you can see that it automatically changes here. So let's get it back to 0.007, and jitter scale is set to 1. All the other things are default. Then we have our circle. In our case, we are using 5 paint blobs, so division set to 5, uniform scale set to 0.54. orientation Z X-plane, primitive type polygon. Then when we drop a copy to points and plug our points from volume and circle here, we can see here are our 5 initial paint blobs. And then we drop a Vellum fluid. Pay attention that we don't need to check this create point from volume because we already have our points. For the particle size, I again copy parameter reference, or not actually paste relative references, yeah. Paste relative references, I'm using that here too. For the settings, surface tension set to 0.05. Friction to 0.1 and viscosity to 0, but I strongly advise you play with these settings. Simulation is pretty fast at 0.007, so yeah, different values here can give you absolutely polar and absolutely different results. For the viscosity, here you can see it's 0, but that's only because we are adding some variation to the viscosity in these blobs. So we drop an attribute noise float, and here you can see that attribute names set to viscosity and the type set to float, and I added this noise Berlin flow. I unchecked output row value, and then I dropped a color with color type set to rem from attribute set to viscosity, and range from 0 to 1, which, because this noise amplitude is set to 1, and that's why it goes from 0 to 1. And here we see that all of our white particles are vicious and black particles are much less. Of course, I want to remap it, so I don't want it to go from 0 to 1, I want it to be from 1 to 5, and this is for sort of like watery liquid. If you want more like a acrylic paint or tar or something, you can go with like from 10 to 50 maybe, or something like that. So yeah, it's absolutely up to you. So here also I add the null, and yeah, for now it's called red geo and red con because I was trying with different Vellum sources. But yeah, you can call it just like geo and con. So yeah, we will be using these in our DOP network here. So let's drop a DOP network and see what we got here. You don't need these, of course. And this is your pretty basic Vellum setup. You have your solver, you have your Vellum object, Vellum source, static object, and the gravity. Static object, of course, for the collider shape. And now in the Vellum source, yeah, let's go and set up the Vellum source. So subpass to the geo, constraint subpass to the constraints, like our red geo and red con. And here we have our Vellum object, which is with all the default settings, and the magic happens here in the pop-wop. So here, oh damn, it's a mess. What do we have here? If you watched my Dior Sauvage project, you could see kind of same or similar thing for the desert terrain generation with noises, but the main thing and the main difference, of course, between these two is that here we are using noise to update the velocity in the X and Z axis, and in the desert terrain buildup we used it only for the Y axis. And basically what you can see here is that we will manipulate the velocity, so we need to break the vector of the velocity into 3 individual parts because we want to target only the X and Z. We don't want to target any or modify the Y, and that's why, yeah, we have our V. It goes to vector to float, then X goes to add, Z goes to add, and Y goes to float to vector. That combines all these 3 values, and then we pass that vector to the V. And for the noise, I'm using curl noise. We want to drag the position P vector to the position of the curl noise, and time, it's also for to make the noise kind of change with time. Of course, we are updating the velocity, so it's not like adding position that if the noise is static, the position wouldn't be updated. But here, introducing a bit more difference in the how noise will evolve with time, it's also not that bad idea. If we plug time directly to the offset, it will be too fast and it will be noticeable that we are doing something with the offset. But if we divide the time by, for my case, it's 7, it should work good. And then for the curl noise, frequency set to 777. And basically the higher the frequency number, the more detailed you will get the noise, because if I plug, I would say, I don't know, maybe 1 or 2, it will be just moving really big chunk of our paint, and we won't get any of these like tiny little swirls, you know. For the amplitude 0.012, this noise, I found it in this setup to be really powerful. So yeah, 0.01 or 0.012 is maximum that I would use, and turbulence is set to 5. Then yeah, we plug these the noise into our adds, and that's basically it for our noise setup. For the Vellum solver itself, I'm using substeps set to 2, and here we have our static object, which in this case, let's talk about it for a moment. So here's our static object, right? This blue thingy here. So subpass set to outshape collider, use deforming, use object, create active object, all the good stuff. In the collisions, RBD solver collision detection should be set to use volume collisions. Collision guide, I just want to see what it is actually, so yeah, I check it. And here is trick. So proxy volume should be set to our VDB collider actually. And then mode should be set to ray intersect, and that's the option 1, right? That's the first option you can go with. So ray intersect, and division method should be set to by size. And look here, so we have our division size set to 0.2. What we can do here is set it to 0.4, and you can see that we are losing some details. But actually there are some, I mean, there are setups where you want your collision to be super detailed. So maybe you want the liquid to kind of rub, you know, the collision. But there are also the cases where you don't need that much details. Maybe you should just get sort of like a really primitive and basic shape. So it's good to play with these values here. And also what you can do here is get your mode to be volume sample. And what it does, it now ignores the division size, but it gets exactly what you plugged in proxy volume, and in our case it's out VDB collider. So it's yeah, that's our VDB collider. I just like to go with a ray intersect because it gives me a bit more flexibility with this division size setting here. But in general, that's it for this setup. Gravity is set to be default, and yeah, we should be good. If you simulate that, it should look like this. So here you can see how the noise is influencing our spheres and breaking all the particles and producing this swirly thingy here. And now let's get to the part where it gets tricky, because I was actually recording this tutorial yesterday and now I'm redoing it because I wasn't sure that I understood it enough to myself, and I spent half of the night and early morning today to really be able to explain you how this works, because I truly think that this is amazing effect and it has so many possibilities and it is so versatile, and I'm sure you will be using it pretty often for all your cool creative ideas. But first of all, I should say that this technique is adopted from this tutorial, which was initially made by CL Mograph, and I was actually streaming live here on Discord when I was doing research for this effect, and Andre and David hopped in and Andre shared this tutorial which explains this concept of freezing the UV projection and applying your texture. However, I did a few things differently, especially in like how the texture is actually applied. But anyways, to be fair, I should mention that I have adopted this technique from CL Mograph tutorial. So here is the thing. What we've been doing previously is grabbing a bunch of particles, colorizing them, and then applying the forces. For this effect, we actually add UVs on our spheres, and then we apply forces. And because we have UVs, they also are being distorted with these swirly noises and all that stuff. And that's how we actually can achieve these swirly results with a mesh, and they look pretty detailed, because if you just transfer the CD attribute to their vertices, and the Houdini will be using promotion algorithms to actually convert the data from the points to the vertices of the mesh, it won't be looking that smooth, especially for the close-ups. But anyways, let's begin. So what I have here is delete node and group set to stream volume source 1 and aberration delete node selected. that's how I can delete everything that I don't need. Let's switch to the camera 2 so we can better see what's going on here. So for now, we need to do a projection of the UVs. Let me just quickly go here in the attribute transfer here, I think. And if you go Command or Control 2, you now have two windows and you can set your view to UV viewport. So here's the deal. We can drop the UV project, and for example here at the frame 9 you can see that when you click this initialize button it will project UVs. Here you can see as I am changing the frames also the UV changes. But the main thing here is that you want to find the frame where they are not like connected or something, so you still are able to paint these in different colors. And for example, I've used Photoshop, and here is the texture that I've used. But basically the main thing here is to just find that one frame, and then you want to lock on that frame. So to lock on that frame we are using time shift node, and here if I go and select it here, you can see that now here, if this one is locked, you can see that actually these UVs, they won't be revealing, they will be overlapping on each other, and that's actually the thing that we need here, because we want to create this effect of swirl and mixing the colors, and you can see how distorted the UV comes here, but it's all good, it's absolutely all right. So yeah, it's all good here. So once we get our UVs projected and locked, then we need to copy the attributes, and we want to copy the UV attributes to our points. Here you can see that on our points we actually have our UVs. Now we can drop an attribute from map to kind of visualize what we have here. And if I will be scrolling it, here you can see how all the colors blend with each other. But of course, for this one, we won't be rendering the particles. We will be rendering mesh. So that's why we need to mesh our particles. And here I'm dropping VDB from particles. Again, voxel size is, remember that 0.007. It is that same from our controls node. And then I drop the VDB reshape SDF, operation set to dilate, VDB smooth SDF, and here I'm using actually the Gaussian, which is not that popular right now, but for the mean curvature flow, I thought it's a bit too bumpy, too much details here, so that's why I went with this Gaussian blur, or actually Gaussian smoothing. But actually after that I still need a bit of reshape, and here the operation is set to open, and then yeah, we convert it back to polygons. And now here's the key point, and we don't need these normals, but the key point here is that we need to transfer the UVs from our projection to our VDB, and this is really crucial here. So of course attribute transfer points UV, because that's what we want to transfer. Conditions here, so max sample count should be set to 100, because here's the trick, and I can visualize that by enabling my render view. And let me zoom in a bit closer here. So of course we are distorting the UVs pretty heavily, so that's why you should go with like 8K maybe texture, or at least 6K. But if we set this max sample count to be like 10, you can see how actually rough it is here. So that's why we need to go with 100 here at the max sample count. And for the distance threshold, I don't know if blend width works somehow, but yeah, I don't think so. But you still see a bit of artifacting here. So what we want to do here is to actually like blur UVs, right? Because, you know, we can blur the position, we can blur the colors, but actually we can blur the UVs too. So attribute set to UV, blurring iteration set to 10, step size set to 0.3. And here we have a pretty good and pretty smooth result here. So that's it, I think. Of course, it all really highly depends on what texture you are using, because this effect is more about like smooth blending. But if you would like to get really sharp edges or sharp lines, just don't apply the Gaussian blur to your textures. Play with different textures. Maybe you can just find something in Google like all these liquid gradients and play with that. Again, this effect is super versatile to me. I'm super glad that I actually spent these 2 days just to understand how this UV blending works. But now to the materials, I think, because for now, if you don't apply any materials here, you don't get any result. Here in our geo, you can see that we have our material, which is here in the botnet. And this material is super simple. I mean, it's just this texture, TX5, color space sRGB, custom gamma 1.7. I set it to be 1.7. I want these colors to pop a bit more. And for the roughness, it's at 2.1 and IR are set to 2. So I have 2 lights. One is here and the second one is here. So that's basically it. It's a really easy setup, but this UV blending thing is, I think, yeah, again, I think it's really good to know and understand. I really hope that this tutorial was informative and you learned something new, and now you can use this technique in your creative process. Hope you'll have fun with it, and I will be back with a new tutorial next week. Bye!